Conservation Commission. And the format that we're going to do today is our speakers are going to give very brief presentations, an overview of their perspective of the fracking world and what they do, their role, and give a little bit of factual information, observations. And then we're going to open up for interactive question and answer. As you've noticed, there are cards and pencils on the table. So what we're going to do, if you want to jot down your questions or comments on the cards, when we come to the Q&A part, I will pick those up, and we'll continue to pick those up and kind of read through and manage our Q&A that way. And with that, I'm going to turn it right over to Steve Jurgens.
Good morning. The presentation I'm going to show you today was provided by the Colorado Oil and Gas Association. And as many of you know, they're an advocacy group for the oil industry in Colorado, whereas our next speaker is with the Colorado Oil and Gas Conservation Commission, which is the regulatory body in Colorado. So I'm just going to give you some basics on why hydraulic fracturing is done, how it's done, how to drill a well, how it's completed. The thing to keep in mind is that the hydraulic fracturing is only one small portion of the drilling and completion of an oil and gas well. Okay. All right. There we go. Okay. Okay. This is an overview of some of the topics I'm going to cover. I'm not going to go through this whole presentation because Stuart will cover some more of these in greater detail. We'll talk about the fundamentals of drilling, horizontal drilling, fracturing. Water management is a big deal, as everybody knows, and then a little bit about what's done with the produced water. Okay, go this way. Fundamentals. Does anybody in the room know when the oil industry actually started in Colorado? It goes back a long way. Believe it or not, 1862, Florence Canyon City Basin, there was a well drilled about 50 feet deep next to a sea. And that was the first actual production of hydrocarbons west of the Mississippi River. So Colorado's been in it a long time. Definition: use of fluids to create a crack by hydraulic pressure. So these formations are under lithostatic pressure up to 700 or 7,000 feet. All of this rock and water stacked on top of it is pushing down on this rock. And to get the rock to split, you have to put an even higher pressure on that rock to create that fracture. The way the fractures are kept open after you release that pressure is you put small granular solids in there. Usually it's just a silica. It's called a proppant, and it keeps that little fracture open so that you can produce the fluids out of it. Why hydraulic fracturing a well? It increases the rate at which a well can produce. It doesn't increase the total reserves. There's only a certain amount of oil or gas there. It just helps you produce it more quickly. Here's a microscopic image of a rock. The little scale at the bottom is 50 micrometers, pretty tiny. These little pore spaces hold the fluid, whether it's water or natural gas or petroleum. Now compare that to the width of a human hair. These little pore spaces are extremely tiny. They're not well connected, particularly in something like the Niobrara Formation, which everybody has heard about. There's lots of porosity there, but it's not connected. You can't move the fluid through it. So the point of doing hydraulic fracturing is to open that pore spaces up so you can transmit the fluids. Here's an example. On the far left, you see if you drill vertically through a formation that's 100 feet thick and you have a 6-inch diameter hole, there's only about 160 square feet of contact with the surface of that boring. If you do a horizontal boring through that same formation and go 2,000 feet, you've increased it considerably. But if you take that same 2,000 feet and fracture it so you have fractures going way out into the formation, you've exponentially increased that surface area that you can produce fluids into. The process is not new. It was started back in 1947, back in Kansas. It's been around a while. It's not something new. It's not something in the last 12 months that's come up. A little bit about drilling. Those of you who have been downtown know where the Wells Fargo Center is. It's about 700 feet high. So take 10 of those and stack them on top of one another. And that's the average depth to the producing formations out in the DJ Basin and the Wellington Field out here for the Niobrara. So you're drowned at about 7,000 feet. The aquifer that you're concerned with is usually in the upper 1,000 feet, depending upon where you are in the basin. So the oil production is way down below where the fresh water is. Multiple casings are installed in these wells. In between each one of those casings there is cement. And every one of these particular casing intervals is set in there for a specific purpose. And the last one that's put in there is called production tubing. And that's the one that's, you actually have to punch holes through the steel out into the formation, and those holes will allow you to push this hydraulic fluid out into the formation. So like I said, the fracking is only a small portion of the process. Surface casing is set to protect the groundwater resources, and the state regulates how deep it has to go in a particular area. Production casing, again, is the final piece of steel that's put down there, cemented in, that helps prevent any fluids from coming up the hole. Drilling depths in the DJ Basin, 7,000 to 8,000 feet is pretty common. Over on the west slope, Piance, 7,000. Piance Mesa, since you're way up there, down to 12,000. And Raton, pretty shallow at 2,000. Okay, fracturing process. The diagram that you're seeing there is actually being perforated, and then they'll push the fluids, the frac fluids out through those perforations into the formation. The fluids that are used for fracking is approximately 90% water. You've got about 9% proppant, and then there's little bits of a number of chemicals in there that help to increase the fluid flow in the formation, is basically what it does. And this presentation is available online. It will be on the CBF website if you want to look at this in more detail, so that you can see what type of chemicals are actually used. I'm going to skip through this, but basically what it says is in 1,000 gallons of water, you've got 3 gallons of the other chemicals that are included in there, so it's a very small amount. Water management is a big issue. The water that is used for fracturing has to be owned legally by the company that's using it. If you remember here a while back, the city of Aurora purchased some water rights from, or the Anadarko purchased water rights from the city of Aurora. So somebody has to own that water to be able to legally use it. So again, everybody knows that Colorado water law is very complicated. So, and there's all those issues associated with it. The amount of fluid it takes to frack a well depends upon how deep it is and what basin it's in. Raton Basin anywhere from 50,000 to 300,000, and Piance Basin up to 2 million gallons. Out in the DJ Basin, in some cases up to 5 million gallons, depending upon how far horizontally you drill out there. Colorado water use, golf courses in 2005 used 14 billion gallons of water. That's a lot of water. In 2010, hydraulic fracturing used 13,900 acre feet. When you calculate that out, that's about 4.5 billion gallons. So to water your golf courses in the state of Colorado took almost 3 times more water than the fracking industry did. So keep that in mind. In 2010, or in 2015, the expected use is 0.1% of the total water used in Colorado will be for fracking. So that's still a very, very small amount. Natural gas has a very low relative use of water compared to some other industries, such as coal. Produced water, what do you do with it? Produced water is the water that's naturally occurring in the formation. All oil and gas production has connate water. Backflow water is water that's recovered after a fracking process. You inject a certain amount of fluid in it, the water that comes back out is your backflow water. Disposal of this water is, about 60% of it is re-injected into the formation. It's used to keep the pressure in the formation high so that you can literally ruin an oil and gas well. If you drop the pressure in the formation itself will essentially collapse, close itself off, and you won't get any more production out of that well, so you'd have to go back in and re-drill. And that's not what you want to do. There are no more gushers like you used to see in the old movies in Texas where it's shooting 100 feet out of the ground. That's never going to happen again. That's a waste of a resource. Some of it's put in line pits, and some of it's discharged to rivers. And all of this is regulated through Colorado Oil and Gas Conservation Commission, and these are some of the rules and regulations. And at this point, I'm going to stop because Stuart will be able to take over this discussion and give a much more detailed information about baseline water sampling.
Thank you for the opportunity to be here today. I'm the engineering manager at the Colorado Oil and Gas Conservation Commission. With the short time I have here, I'd like us all to ponder the question of why horizontal drilling and hydraulic fracturing are considered controversial processes. The media and the opponents have coined this expression as controversial, primarily as a result of some reported incidences that have occurred in the Northeast and Mid-Atlantic states, where oil and gas drilling is relatively new and regulations are sparse or outdated. In contrast, here in Colorado, we've had an active oil and gas industry for quite a while. Hydraulic fracturing, as you heard just recently by Steve, hydraulic fracturing and horizontal drilling is not new to Colorado and actually has been used for decades. The Oil and Gas Commission has had rules related to the protection of our state waters, including surface waters and groundwater since the 1950s. And the Commission, we've been doing some public outreach since 2008 regarding this subject. And I didn't quite at that time realize that how much information the general public desired on this subject, and that we'd be spending so much time. But in doing all these presentations, I've come to realize there's kind of three different groups out there that one of the things I want to do today is try to give you some clarity on that on this subject. The thing I've come to realize is there's kind of three different groups. And I'm not trying to label anyone in particular, but we all have different understandings and different perspectives. There are those that you might say are the industry supporters, those who have an understanding of hydraulic fracturing, horizontal drilling, and believe that it can be done safely and it's directly related to our needs for energy. There are those that are industry opponents. They pretty much want an all-out ban of oil and gas activities, and they have a variety of reasons that they've expressed. You've heard many of those in the press, or they just simply don't want it in their neighborhoods, in their backyards, or near them. But the majority, and probably a good portion of here today, are really people that want to gain more knowledge regarding the oil and gas industry, hydraulic fracturing, and horizontal drilling, and want to hear that or understand that it can be done safely. My answer to that third group is that hydraulic fracturing, horizontal drilling, oil and gas exploration and production can be performed in a safe manner, and has been done so in Colorado for decades. The best example I can provide you is North Metro Denver. Within North Metro Denver is the 10th largest gas field in the United States. There are over 20,000 active oil and gas wells. Kind of depends on where you draw that line. It could be a few more, actually. But that is the Wattenberg field. It was discovered in 1970. Of those 20,000 active wells, all have been hydraulically fractured at least once. At that same time, we all know that that's a growing metropolitan area between Thornton, Brighton, all the way up to Greeley is the rough geometry of that field. There are also over 20,000 active domestic water wells. Normally, I kind of give a presentation, much like you just heard, on the technical aspects of oil and gas, how a well's drilled, actually the details of hydraulic fracturing. But what I'd like to do right now is kind of step away for a second. And what I'd like to do is talk about exposure. Now, I'm not a toxicologist, but I have participated in a few discussions with the Colorado Division of Public Health and Environment. And they talk about the need for 4 basic elements to have an exposure. You have to have a chemical source, that would be our oil and gas well. You need to have an exposure route. You need to have a transmission medium. You need to have a receptor. That'd be you all in the general public. In addition to that, you need a chemical concentration, a dosage, and you need to have an exposure time at that receptor that's going to cause a significant adverse reaction to occur. So let's take a look at those 4 elements again. While a chemical source and an off-site receptor are present in any industrial process, including oil and gas exploration and production, we here in Colorado have several rules related to eliminating that exposure route. When the exposure route is eliminated, there is no exposure. As a result, when you take a look at the inventory, over 50,000 active oil and gas wells in Colorado, over 90% of those have all been hydraulically fractured. At this time, our staff is unaware of any impact to a water well or our aquifers as a result of hydraulic fracturing. You're probably asking yourself right now, how can that be? Or I've been told of past instances that have occurred where there's been impacts of hydraulic fracturing to our groundwater. Well, as the engineering manager, this is kind of the perspective we place on this subject. We have several rules regarding how a well is constructed, and we saw a bit of that just a second ago. Steel and cement, isolating the aquifer, isolating the hydrocarbons. The casings need to be pressure tested to make sure they handle the pressures that are applied. We do as-built drawings like in any construction project. They have to provide us petrophysical logs that verify the geologic formations and the cement and the quality of the cement they've placed in the hole. While they're doing the hydraulic fracturing treatment, they have to pressure monitor to make sure we don't have a pressure breakdown. And emissions of the flowback need to be collected as soon as practical to make sure we don't have emissions. So I've just been handed a card that I'm running out of time. So we've already had the fact that a wellbore needs to be built right. And you need to manage and handle those pressures. Since we know that 90% of the wells are hydraulically fractured, from the very get-go, you know what pressures you're going to apply. A wellbore is a structure. It's the building we're in. The designing engineer knows the applied stresses put on that building, and the wells are a construction project, and they're designed to handle those pressures. Environmental rules, we've got several environmental rules in place to make sure we have appropriate setbacks from drinking waters, best management practices, just like you all might place in your construction projects. These need to have appropriate BMPs placed to manage any surface waters and any spills that are contained on the site. Lined pits, closed loop systems, once again, eliminate that path of communication between our water supply. Anytime there's a spill, it needs to be reported to us immediately. We have groundwater sampling programs. In 2004, we started collecting water samples in the Durango San Juan Basin, and in the Trinidad Raton Basin, we collected water samples. We've also been collecting water samples in that North Metro Denver Wattenberg field. Just recently, we adopted a statewide water sampling rule that collects a before and after water sample. As far as inventory and chemical disclosures, you all in this group from your projects know that MSDS sheets are required on all projects. So that's been a requirement from for quite a while, as you all know. But there was a desire for many folks to have that, the actual physical chemistry of each treatment, and you can get that through a website called fracfocus.org. And so each treatment, you can search for wells and locations. So kind of in closing, want to point out that sort of going through our mission statement, we are a group that was started in as far as regulations of the state of Colorado in 1951 with our mission charter to protect our waters of the state, all the way back into 1950. Protecting the surface waters and groundwater. We also do have that concept of making sure that oil and gas is developed in a responsible manner. A manner in which protects the public health, safety, welfare, and wildlife, along with the correlative rights of those mineral owners. And the implementation of these rules have prevented downhole impacts, as I kind of referenced before, from hydraulic fracturing and oil and gas activities. And anything different than that would be against our charter. So with that, I will pass it on.
Great. Thank you, and thank you to all of our speakers for working within our constraints here in the format. I'm going to circle back again while I get Leonard set up here. So we just heard from the engineering side of things. Steve, I don't know if I mentioned, Steve, you spent time out in the field as an engineer in the petroleum fields. Great perspective. Stuart gave us an engineering perspective from the regulatory point of view and how they work. We're going to start to transition this discussion now. I'm going to bring up Leonard Slosky, who's been looking at different case studies, stories, anecdotes, myths, facts, stories, and he's going to do a little myth busting for us, and then we're going to transition to talking with our communities for Lupton and Brighton.
Thanks, Jesse. I have a minor challenge here in that I'm going to try to summarize the environmental impacts of fracking in 10 minutes. Here's a list of some of the potential environmental impacts. For any of you that have studied this subject, it is extremely difficult trying to separate out in the literature the impacts of fracking from the other aspects of oil and gas production. Most of the studies don't separate them out. Most of the statistics don't separate them out. In addition, the regulations have been changing quickly. As Stuart mentioned, the COGCC has been ramping up their regs in the last few years. That's been going on nationally as well. So it's a changing regulatory framework, so it's hard to assess impacts. In addition, industry practices have been changing, in some cases fairly dramatically. It used to be fairly common to inject diesel as a fracking medium. That is virtually not used in the U.S. anymore. You can imagine the potential environmental impacts of the diesel if there was a leak. My personal view is that a lot of the controversy comes from not just the allegations of the contamination, but oil and gas development and fracking are industrial operations. And when you do those in close proximity to where people live, it's uncomfortable. There are documented cases of methane in water wells. A lot of that has to do with the location of the water wells. A lot of water wells are drilled in geology that have methane in them. So all of you have probably seen the documentaries or other things where people can light the water coming out of a well or a faucet. That does happen. In most cases, that has nothing to do with the oil and gas development. It has to do with oil and gas development occurring in the geology, which also results in having methane in water wells on occasion. When you have thousands, tens of thousands of wells, you obviously have leaks and cleanups and activities that have to occur. These are data from the COGCC, and unfortunately, it doesn't break out fracking. This is for oil and gas generally in the state. There are a couple studies that have tried to investigate the source of problems from oil and gas development. And here are two of the longer term studies that I'm aware of in Ohio and Texas. And you can see there are over 300,000 wells that were included in these two studies. And they actually found 0 problems that were directly from fracking. But as you can see here, there obviously are problems that occur in oil and gas development. I'm going to skip over the case studies so I can try to finish close to 10 minutes. I have some handouts on the front left table that have these in there. And what I tried to do was to go back some of the allegations or so-called documentaries that alleged various impacts in Colorado. And I went back and tried to research what the source of those impacts were. Some were from oil and gas development. Many are not from oil and gas development. As some of you may know, EPA has been in the process, US EPA, of doing a fairly comprehensive study of the impacts of fracking on drinking water resources. That study was supposed to be out late last year, but now they're saying that the draft is going to be, the draft is going to be in late 2014. It's taking a pretty comprehensive view of the issue from a water standpoint. It's not looking at all environmental impacts, but focusing on the impacts on water resources and water quality. They're looking at a number of different aspects of this, and they have at least one case study that I'm aware of in Colorado that's included in that study. So I think this is going to be a landmark event when this comes out, and it's going to be out for peer review as well as public review in the coming years. Because it's an industrial operation, there are environmental risks inherent in oil and gas production. Fracking increases the risk slightly. The data that I've been able to collect shows that more than 99% of the fracks show no impact on aquifers. You need to understand that fracking is occurring in many geologic media across the country, across the world. Sometimes the water wells are in close proximity to the fracking. That obviously increases the risk. In Colorado, most of the fracking is separated by thousands of feet horizontally, as been previously mentioned. The risk of a deep frac water entering an aquifer is estimated at about 1 in 100,000. Getting gas into an aquifer, you can see, is much greater risk. Shallow wells have a greater risk, and refracking older wells have a greater risk. They may not have been constructed to current standards, they may have deteriorated, etc. As I mentioned, oil and gas development and naturally occurring methane in water wells is a common occurrence. Other speakers have talked about the water. There is a significant amount of greenhouse gas emissions from fracking in oil and gas production. There are efforts underway to reduce that. One of the most controversial aspects has been earthquakes. When I gave this presentation last fall at another CBF forum, there was one documented case I could find of an earthquake from fracking there. There are now 2 or 3 additional cases. Very, very rare. These are felt earthquakes, no damage, but they're above magnitude 2. So that is something that has now been documented and probably will increase. I've given you some of the references for those of you that are interested in the literature and my contact information. Thank you very much.
We have 2 communities that we have here at the table. Fort Lupton allows oil and gas extraction from their cities. Brighton is going through, well, I guess you'll update us on where you are on your thought process of where that is going. I'm curious about that too. I'm going to invite Manuel up here to talk about Brighton.
Thank you, Jesse. It's a pleasure being with you here this morning. You know, it would be good for me to know who we're speaking to. And just for the sake, if I can take just a couple of minutes of asking who you represent, can I see how many are with the industry, with the oil and gas industry? Do we have any of those in the audience? Kind of. What about cities and counties or government? Okay, great. How about just professional engineers or associate in law? Law. Good. Any others that I didn't mention? Environmental consultants. Okay, great. Thank you. Well, it's helpful for me to know that. It's always good to know who you're speaking to. Again, my name is Manuel Escobar. I'm the city manager for the city of Brighton. As Jesse mentioned, we're going through a process right now of really trying to define what role does the city of Brighton play in regulating the fracking oil and gas process that's taking place around us. Brighton sits right in 2 counties. It sits, the majority of the city is in Adams County, and a smaller portion is in Weld County. So as was mentioned earlier, the city of Brighton sits just a little south of the major activity oil field that's going on right now. And we're beginning to see a tremendous amount of activity taking place from an economic development perspective in terms of how the oil and gas industry is starting to infuse the type of stuff, the type of interest, the type of jobs that I'll talk about here in a second. And now we're starting to see that the oil and gas industry is looking at, okay, where in Brighton within our city limits or our growth boundaries, or in the counties just right outside of our growth boundaries, where is it that they're now looking at placing those wells? It's interesting, we have not any wells as of yet, and we're just right smack in the middle of the Libera field, but we have not had that opportunity. The majority of it is happening in Weld County, and the mayor of Fort Lupton will share with you the activity that's going on in his city, which is much more than ours. So in preparation of that, the city has been going through a lot of discussion, and I think the first presenter presented the discussion as to what is going on, what's happening, and a lot of misinformation, a lot of myths are out there. And so it's very difficult for city staff as well as the city council to begin recognizing what is this? What is this process taking place? And then of course the community itself the citizens themselves find themselves in a situation of asking the same question and saying, okay, if in fact that happens in Brighton, what is that going to look like? And what's that going to do? And how is that going to affect our operations? So in addressing that, I'm going to go through this very quickly here because I have a lot of slides and obviously I can't relate to all this. But the first brief slide, we really took the time to educate our city council, saying, okay, let's get them the information that they need so that they feel comfortable of understanding what is fracking, what is taking place, and how is that related. So we went through a lot of process, and this is just a summary of the activity that we went through in defining that to the city council. Our first presenter was one that we wanted to bring an outside perspective. We wanted to make sure that someone that was not related to the oil and gas industry, but could tell us what in fact this whole thing of fracking is all about. So we invited Dr. Will Flickenstein to make a presentation to the City Council. And he's with the School of Mines, engineer from the School of Mines, a professor there. And he went through a process of just taking us through what is fracking. And you've seen many of these slides before. He actually took the council through an in-depth process of getting them to understand what it is, how the process works, how water fracking is done, and it was a very educational component for the council first to hear about that process. Secondly, we went through and said, hey, let's bring the industry this time. Let's have them talk about, from their perspective, who are we? What do we do? How do we want to work with the cities? And we brought in the Colorado Oil and Gas Association, and she provided to the council what in fact the mission of the oil and gas industry is in educating the general public of what's taking place. Did an excellent job from their perspective, although biased, and we all understood that. We recognize that she did a great job of saying, hey, we're not here just to put wells wherever we think we need to put wells. We're here to work with the community to understand that it is important that the citizens understand what this process is all about. It's all about, you know, I've had a chance, we have a lot of, and Tommy has the same scenario, we have a lot of oil and gas workers in the community now. And it's not the same as it was many years ago, where it was all based upon hunch, you know, that where do you put a well? And as we think it goes here, now it's very, very scientific. We have this huge machine going through the city that is a seismograph that, you know, actually can tell where in fact they would like to prefer dealing with those issues. So it became very important that we recognize that it's no longer a hunch. It became an issue of how do we process that process. So she went through this process of talking about how they went through it, how the casing is, how they protect, how they perceive that they protect groundwater, which is a critical aspect for the city of Brighton. The city of Brighton is probably the largest city that uses the majority of its water from well water. So it's extremely important that we look at this carefully to ensure that when we allow this process to take place, that we have to protect our groundwater and the shallow groundwater. Here's a good example of what it was, you know, 1903 in Boulder, of what it looked like at that point in time, based upon a lot of good hunches, okay, of what's happening here. And then here's what it looks like today. And so there is a huge compassion, I believe, from the industry that recognizes the importance of environmental issues. We also brought, because we are in Adams County, we brought Adams County to talk to us about, okay, what's their process? How do they allow for fracking to take place? And what rules and regulations do they have in place? So they were able to share with us a lot of their activities. We did the same thing with Weld County, and we brought the Public Works Director from Weld County to tell us what's their process and how do they relate to the activity that's taking place in Weld County. Here's a good picture. I kind of enjoy this one. this kind of defines what was talked about earlier in terms of where the concentration is of the oil is. See if I don't get Tommy's eye here. So, Brighton is about right here, I believe, in this area over here. So you can see we're right in the sail end of it, but we're beginning to recognize a lot of activity. A lot of the workforce has in fact located in the city of Brighton. So it's a large area, and it's going to be a large area for some time. Here's the well county talked about what to expect when we get seed wells. So here's some pictures that they provided to us. And they also looked at how we can begin looking at other aspects associated to that. We also brought in some environmentalists. Jesse was a major component of that. We asked Jesse to come to talk to the council about how does the environmental aspect relate to, and we brought an associate of his to also talk about the environmental process. A lot of questions that came about, a lot of diagrams, again, trying to explain that process. We also were able to do a tour in Greeley. Greeley has, I believe, 400 and some wells within the city of Greeley, city limits of Greeley. So they've been through that process. So we spent the time, we jumped on a bus and took the council members to Greeley and met with the Greeley mayor and all the staff there, associated 419 wells, active wells right now. And I think there's 55 pending and 191 that's just recently been approved. They talked about their impacts as well as economic impacts. And they gave us a little tour of where some of these wells were. The other major portion was the economic impact. And so I'm not sure if you recognize this. Patty Silverstein is an economist, and we asked her to say, hey, can you help us get our arms around the economic impact? What does this bring, and how does this relate? And she was able, the interesting quote that she shared with us is there's not a lot of study that's done in this area. There still needs to be more study done relating to the economic impact. A lot of study done on environmental and everything relating to that. But very little work has been done in relationship to the economic impact. Here's just a quick example of the permits, and then we also have some of the direct impact in terms of employment that occurs not only in Colorado, but also in Adams and Weld County and the rest of Colorado. Talked about the average wage, this is interesting, I need to say this real quickly. The average wage for Adams and Weld County in the oil field is $75,000 compared to $42,000 for all other industries. So it has presented to us the understanding that this industry pays well. All the permits, it also talks about the benefits, property tax, severance tax, federal mineral lease, royalties, not only to counties, but also cities. Cities have ownership of property that some of these industries have a strong interest in drilling on the site and giving some royalties, as well as the license and permits. There are the social benefits that relate to all this, and we'll get into that. I've got a minute here, probably 30 seconds here. The last areas that we've been really working with is, okay, now with all this information in your pocket, how do we get that information out to the general public? And so that's what we're doing now. We're trying to do as often as we can, get this information in different groups to the general public to let them know what we have found and what we've learned. We've also been working very closely with the Colorado Municipal League, who's been working with the commission, who's established a special task force, as I understand, to begin looking at this situation, so we've been learning from that process. So where we are today, we're right in the middle of that process to continue to adopt, look at what else has happened, who else has regulations, and how can we adopt those, why do we have to reinvent the wheel? But there are certain aspects that we think we want to make sure that we have addressed and continue to address. our biggest issue right now, rather we're waiting for the adoption of these regulations because there's some stuff going on the state level. And we want to make sure that we can get a better understanding of what the state is actually going to end up with as well. So thank you very much.
I just want to start with, in the city limits of Fort Lupton, we've got 100 wells. Within 5 miles of the city, we've got 2,500. We've been dealing with this since I was a kid. I mean, we've got wells on the farm that I grew up with. I live right next to 3 wells right now. And so we've kind of, in Weld County, it's part of the landscape now. Part of the business is going to change, and that business has not been good. In the late 90s and early 2000s, I've been on both sides. I've been on lawsuits with oil companies because they didn't play nice at that time. But, you know, they were riding roughshod over cities, over developers. They wanted extortion money, basically. But with the advent of technology and some new people, some personnel, it has completely changed. And so we've made those partnerships within the city. When you start looking at a horizontal well that they can drill, the one I saw yesterday in the newspaper was 9,900 feet. That's 10,000, almost 2 miles that they can drill. So a lot of the times the impacts to the cities that, you know, people they think they're going to see, they're not going to see it. At this time right now in Fort Lupton, we've got some wells that are going to be located about a half a mile from town, from the city limits, and they're going to drill all underneath town. It's going to be done, and nobody's even going to know it. And so with the advent of technology from a land use standpoint, it's really helped out. And any time we've built those relationships, and even if it's on, I would encourage government officials to be involved with outside your city limits. Sooner or later, you're going to annex that property. You don't want wells right in the middle of it so that you can't use it for anything else. Make sure that it goes in the corners. We've done that. Anytime we get permits, Oil and Gas Association sends it to our local government designee, and we go back and we check and see where those wells are going to be. And if we have a problem, we don't go to the Oil and Gas Commission, we go directly to the operator. It's like, you guys need to come in, we need to talk. And we've built those relationships, and that way you can nip a lot of that stuff in the bud initially. It makes it a lot easier to get those things done. New technology has really changed the game. I mean, it's changing every day. And this is not going away. Noble is going to put $1.5 billion into the system within the next 3 years. Anadarko is going to match that. We've got 20,000 wells in Weld County, and since 2010, our assessed value on property values has gone up $1 billion every year. And it's going to happen again this year. Today I've got to go to another function at Ames Community College where Anadarko and Noble together are going to write a check for $148 million to the county of Weld. So it's a huge economic impact for everybody. Weld is the only county in the nation that's debt-free. We've got $100 million in the bank in cash. And a lot of that is because of ag, and a lot of it's because of oil and gas. And we've learned how to make oil and gas work with the rest of the industry that we have there. And so it's something that can be done. And I would encourage any of you to call me, call the Weld County Commissioners. I mean, if you guys are looking at having some activity in your area, utilize those people so that they can come in and see what their experiences are with it. And like I said, not all those experiences have been good over the years, but the operators have gotten a lot better. Current activity it's still going up. We're seeing it through the Oil and Gas Commission. I think vertical permits are starting to drop off. They're just not as profitable. They can do it with horizontals so that you don't have as many pads. They're starting to put all the pads on, one location. They'll have 6, 7 wells so that you don't have pinholes all over the place, which has really helped. But the economic value of it, when I got out of high school, I grew up in Fort Lupton, married my high school sweetheart, the whole story. If you couldn't find a job as a janitor, you went to the oil field. And now, it's a career path. I mean, a high school education, you can get 6-figure income. The disposable income that has come into the city of Fort Lupton and to Brighton, that whole area, is huge. Just in the city limits of Fort Lupton, we've added 1,500 jobs in the last 2 years. And it's continuing. I mean, and those are the ones that we can track, the Halliburtons. But some of the smaller service companies, we don't know how many more people that they've added. All the businesses are up 20%. I don't know what you guys are. Probably pretty close. But because of oil and gas and the activity and the disposable income, we're saying come on in. I mean, it has been a boom for Fort Lupton, for Brighton, for all of Weld County. There are some impacts. We've tried to get out ahead of that. We've got the Niobrara Council, which probably the biggest impact that anybody's going to feel is going to be traffic. And so we've tried to get ahead of that. And so we're working with industry. The county's throwing in about $9 million a year. The industry is throwing in $9 million a year. We've got haul routes. You know, we're just trying to control some of that stuff in the beginning. I mean, I've even gotten to the extent of getting a newspaper from North Dakota, from the Bakken, just to see what problems they're going to have so that we can anticipate that and try and get ahead of it. And those are just some of the things that we're doing. But we've been dealing with oil and gas for, you know, since I was a kid. And Fort Lupton sits right in the middle of the Wattenberg, and it's not going to quit. It's going to continue. So that's basically what I got to say.
So there was mention of pinholes versus and a whole array of wells being replaced by single pad sites. Do we have, I don't know if anybody's mentioned kind of what the ratio or the reduction in surface wells are as we move towards a horizontal drilling scenario?
It's a little hard to answer that discreetly with exact numbers, but if you take a section, land section, approximately the Wattenberg field is drilled on 20-acre spacings. So roughly, you're looking at 32 wells. And each well would be a little over an acre of disturbed area. Now, if we drill that same area with horizontal wells, it'll drop down to probably less than half those number of wells. So we're more in the horizontal sense, we're somewhere, depending on how this all plays out, but you're looking at 8 to maybe 16 wells exploring that same area. Now the wells, you could put, and that will be done with 2 pads. So let's go with 16 wells. They'll do 2 well pads, each more in the range of 5 acres of disturbed area. So what I initially said was 32 acres of disturbed area in vertical wells can be changed to 2 well pads, each maybe in the 5 acre disturbed acres in size. And they'll have 8 wells each on there. So right there, that's a huge benefit from a disturbed area perspective. The next piece of the puzzle is if you're talking combining all those impacts. So we're driving to only 2 sites. So you saw the picture with a large volume of vehicles, but those vehicles are now driving to just 2 sites. So as Tommy talks about the haul route, now we're rehabilitating, asphalting and rehabilitating just this one route because it's going to be along one section. You're going to locate it on one section line. Now we've got that 8 well pad, 2 pads developing one section. We're going to turn our drill rig. We're going to go south now. We're going to do the next section to the south. So we're going to have 8 wells going to the south. So now I've taken my 2 well pads and I've replaced those 32 to the south. So 2 sections can be developed with, that would have been 64 wells, are now all combined on 1 well pad. And so logistically, all of that kind of all combines. Now, we're not saying that if that was your house right next to that pad, you're not going to be all that happy. So we need to get appropriate best management practices, mitigation, and setbacks in place to make sure that that impact is minimized.
Okay, so I've got a couple of related questions here, so let me try to paraphrase and hope that I capture everybody's intent here. When the Colorado Oil and Gas Conservation Commission stated that no water has been impacted by fracking of 90% of all the wells in Colorado, what does that actually mean? Is there no hydrocarbon contamination, no hydraulic fluid? And there's also I believe a related question about how does that relate to something like what's going on in Parachute right now? And accidents, and if it can be done safely, why does that water contamination happen?
Well, let's make sure what we're talking about here. Let's separate the concept of, and this is where I get, there's a little disconnect going on. Hydraulic fracturing is the process of hydraulically pressuring the formation to make a crack. That's hydraulic fracturing. Now, if we're talking about a spill on the ground, that's a different subject. So I don't want to get mixed up here. So let's take example Parachute, that incident. And what that is a leak on a pipeline coming out of a compressor station. So that's a pipeline leak. So that's what's occurring on the Parachute side. Next is if you have a spill scenario, let's say you have a surface equipment, a piece of equipment called a separator. If that piece of equipment leaks and oil and gas or oil or produced water go on the ground, that's a spill. And so that's kind of what we're talking about. So what I was trying to say when I say downhole hydraulic fracturing, the pressure treatment of the rocks and the breakdown of the well bore, that's what I was talking about. We don't know of an incident of an oil and gas impact from that pressure breakdown. Think of a well, you could think of the well bore as a pressure vessel. So I'm saying we don't know of the pressure vessel, the well bore breaking down. And in oil and gas, now you guys probably know this far better than I, in oil and gas and the federal rules, anything coming out of the wellbore is classified as exploration and production waste. That's a specific federal classification. So whether it's hydraulic fracturing fluid, produced water, oil, if it's coming out of the wellbore and lands on the ground, we would consider that a spill, an exploration and production waste, and needs to be cleaned up and brought back to the appropriate standards. And we have a table 910. That's it. So that's kind of my
And so kind of related question to I think any of you on the panel, it comes down to that question of local regulation versus state regulation. And if there are spills that can occur, why would it be better? Why should the local government regulate or not regulate?
Well, let me just first say, at least in part, our staff is we've got, it's a little dynamic. You probably read the paper. We are adding staff, but we have somewhere around 80 people, all knowledgeable on oil and gas. I brought our book just to kind of give a reference that it's not just a little book. It has a lot of rules and regulations. We have a relationship with the Colorado Department of Public Health. They regulate things like groundwater quality and soil remediation. We work with them, and we believe that we should regulate that downhole construction, and that's where our role is. We also believe that we have the knowledge base to deal with oil and gas activity. In our permitting process, we have what's called a local government designee, and we encourage that relationship. So we at the state want input on all the permits that have come before us, and we solicit that comment. We also have a permitting process as an automatic email. So every permit we get, an automatic email goes out to a local government to solicit that input. So from the permitting stage, we try to get input from the get-go. So that, and we believe that the local governments do have local knowledge that need to be implemented a part of that permit. So we solicit that input.
So in terms of Brighton, Fort Lupton, do you perceive what you guys are doing in your communities as regulation of the industry? How do you perceive what you're doing? Is it a good thing?
What we do in Fort Lupton is just try to mitigate. And most of it's noise. I mean, a lot of the impacts that you're going to feel are going to be temporary. The drilling, the fracking, they're going to go away, so we get with them. And it's come to the point where we brought the operators together to the table and said, okay, if you're going to operate within the city limits, you're going to have to start acting more like a developer. And so we're going to want to see some berming. And I've seen some stuff in California that looks like palm trees, and they're actually oil rigs. I mean, there's a lot of things that they could do to mitigate the public perception of those rigs, or not the rigs so much, but as the batteries and the Christmas trees, the facilities themselves. But we bring them in for a permit, and then we make them put up maybe hay bales, do whatever else we can. We just sold a bunch of water to Anadarko, who instead of having water trucks on the road, they're going to put pipelines in so that we can get the trucks off the road. So that's helping as well. But we've got 28 wells in the city limits of Fort Lupton, and none of them have been affected by any of the oil and gas activities that we've had within the city limits. So and there's 100 of them there.
You know, I believe that City of Brighton is looking at the process in terms of what is working and what's working in other facilities, other cities, and how can we adapt to those particular issues. We recognize that the City of Brighton is regulating land use, okay, and that's important. And I think the citizens, from their perspective, they strongly believe that quality of life is something that we have really worked hard in developing. So how, when we talk about bringing an industry into the city, how does that industry, such as oil and gas, how do they relate to that quality of life effort? And from our perspective, I think we see the necessity of looking at that land use effort from that perspective, whatever that might be. But we also look to the state to work as partners with them to recognize that, as I indicated to you, the City of Brighton really has a concern about water and our shallow wells. And we are recognizing that that's something that we have a difficult time regulating, but at the same time it is a concern. So I think it goes back to what Mayor Tommy said earlier, and that is that you have to work with each, from our perspective, from our understanding, you got to work with each entity that's doing the drilling and sharing with them what is it that we feel important to our city and how can they work with us. And we're hearing that that's been a good partnership.
Interesting. There's a kind of a comment, it might be my interpretation of the comment, but what the question is about industry advocates and having a more well-rounded panel. I'm not sure if we're talking about this particular panel or just in general. But when we put this session together, the full intent was to provide objective information, and it's kind of curious. I personally, I am on the fence on this thing. I keep hearing more information and trying to learn more, and I'm not sure if I'm pro or con on horizontal drilling or not. So it's really fascinating to me. And as we're putting together this panel, it was really trying to pull together expertise in an objective fashion, and it's sometimes it's hard to not envision everybody up here actually being being in support of it, but I think everybody's trying to deal with it. Have that perspective, and with that in mind, there's a lot of questions about safety, and there's some questions for Leonard. One of the questions is regarding, you showed some information on spills and sizes, and do you have any information from what you were able to research on what is a large spill, what's a small spill, how often they happen, a little bit more information on what it means to have a big spill or a small spill?
Well, I think as you can imagine with the, I guess in some cases, millions of gallons of fracking fluid being used, there's the potential for large spills. I think the industry and the regulators do an incredibly better job at that than, was done decades ago. I mean, I've worked on sites in Colorado where you have activities that have contaminated the soil and endangered the groundwater, and COGCC has ordered groundwater remediations in cases where that has occurred. So I mean, I think you could plot a frequency chart, and the small spills are quite often.
Is it a geographic area or spread?
I mean, it can be, a few gallons. Or, if you have a tank battery that ruptures or a pipeline that leaks, it can be quite significant. But I think, both the industry and the regulators are doing a much better job at identifying those early and acting to get them cleaned up. But as you see in Parachute, it's not a perfect world. You see other pipeline spills. But there was a big one in Montana, was it last year? They can be a challenge when you get petroleum loose in the subsurface, but the frequency of the large spills is quite rare if you look at the number of wells and number of pipelines.
And another related question, this is one of my questions too, is the seismic activity, and is there a real concern that we're causing earthquakes or not? And I don't know if Fort Lupton has felt any shimmers getting your margaritas mixed up for you. Do you have any more insight you can throw on that from your research?
Well, I think it is a risk, but it's a small risk. As if you look at the thousands and thousands, tens of thousands of wells, and they're now 3 or 4 documented earthquakes. They're quite rare. All of them that I'm aware of are quite small. Some of them are felt. And you also need to understand that there are other oil and gas activities that can produce earthquakes, where you have the deep well injections. If those are not done properly and those lubricate faults, there's a much larger number of waste disposal related earthquakes that have been documented. That there was an earthquake problem associated with the deep well disposal at the Rocky Mountain Arsenal a number of decades ago. So we know that can happen in Colorado. I'm unaware of any documented oil and gas related earthquakes in Colorado that have been felt. There's an anxious question in that.
Yes, Liz.
There was a USGS study conducted in April, was delivered in April of 2012, that inextricably linked deep well injections to earthquakes in the Raton Basin. And I can read from the abstract if you need me to, but I believe most of you should be aware of that study.
Yeah, that was done by Dr. Ellsworth, not any relation. And we are studying that, and there's a little bit of a disagreement in that scenario. The earthquakes that are occurring in the Raton Basin are isolated to 3 locations, and they are occurring at, of course, they always talk about meters. The injection in that area is occurring at about 5,000, and I believe the earthquakes are occurring at, I'm going to give a rough number, 20 to 30,000 feet. And since there's so many engineers in the audience, I want to make sure that everybody realizes how earthquakes occur. And you might all recall your triaxial test from your schooling in the past. And if you look at the Moore-Coulomb failure criteria, it's a result of pore pressure changing. When you slide that stress field across and you change the pore pressure, that's how an earthquake moves. It's not a friction scenario, so it's a pore pressure change. So that's kind of the relationship, and I think there'll be more discussions on that over time. Yeah, the correlation to induced earthquakes is related to altering the pore pressure when you induce extremely large volumes. The Arkansas, Texas, Ohio, and the Rocky Mountain Arsenal, they were all injecting into granite rock. So we can all kind of visualize it'd be pretty easy to change pore pressure when there is no porosity. So in the rocks. And so one of the keys when we do our injection reviews is to make sure that the rocks do have pore pressure, or do have pore space to allow the fluids to enter.
Is there a way, like you talk about specific studies and interpretations, is there a way to, you know, if citizens or local government has questions about specific studies, do you think we can pull together a forum, the author, I don't know whose purview that would be, is there a forum to pull
Yeah,
together?
example, the Groundwater Protection Council did a induced seismicity study that was in Florida. They do several of them. I think it was in the Tampa area, and I presented much of the retone type information. And there's a Paradox Basin study, Paradox Valley study. There's the Rocky Mountain Arsenal study and the Rangeway study here in Colorado. I can't remember where Dr. Ellsworth presented that, and Los Angeles, I believe, is when he made that abstract.
I'm wondering it's on the edge of that too.
Yeah, I just wanted to mention that this last year, the National Academy of Sciences released a report that reviewed seismicity associated with a variety of energy technologies, not limited to oil and gas, but including oil and gas. And they listed 3 documented fracking-related earthquakes, failed earthquakes. And those of you that are interested in this subject, I'd refer you to the National Academy study. And if anyone wants a specific reference, you can email me, and I'll be happy to send it to you.
Obviously, we can't answer, these are some great questions and great thinking going on behind them and great concern. Let's take, we can't answer everything here, but hopefully we get you all thinking about it, maybe making some contacts, and if there's a way we can help you put things together. Got one last question. We're a couple of minutes over. Let me throw it out here. It's to Mayor Holton. Please expound upon your community planning around new wells and how you want to put the wells in the corner. What efforts are in place to plan for community growth, and what is the growth demand that you're seeing? Here you go.
Basically, what we do is when we get somebody that wants to come in, an operator wants to come in and drill a well, we sit them down with the surface owner and with the city's comp plan, and to see how that's all going to work into the existing plan. And basically, we just sit down and we make agreements that make it work for all parties so that we can preserve as much property as we possibly can. We've got one location right now that is just across the street from Halliburton. Oil and gas wants to come in, and there's about 15 to 20 acres there, and they want to drill right in the middle of it. And that doesn't work for me. We've got a road that's going to go through there. It's an arterial that's going to make it prime property, and I want to reserve that property for I-1, I-2, and so we're working with them. You know, we have been for the last 6 months, and nothing's come to close yet, but we're getting closer. There are some limitations about how far they can kick the horizontal, but we're confident that we're going to be able to put something together and get it located in a location that's going to work for both the operator, the city, and the service use.
Great. And we will have all these presentations that we have will be up on the website in the next few days. And are you all going to be around for a little bit? Maybe some questions? Great. Well, with that, I'd like to thank our panel for being here.